2017年嘅第7條題目又去到破解 SBA 啦。今次呢幅圖咧就顯示一個實驗裝置啦，就想去調查一下光度對於一棵植物嘅光合作用嘅速度究竟有啲咩嘅影響嘅。咁呢幅圖啦，亦都顯示咗我哋個裝置咧有把間尺啦，咁我哋有個燈膽啦，就可以移近啲、移遠啲嗰棵水草嘅。咁喺呢個量杯入面咧，入面載住咗水啦，亦都有一個漏斗咧去吸住咗呢棵水草，亦同時咧亦都可以引導咗呢啲氧氣去到一個倒置咗嘅試管入面嘅。所以啦，呢個倒置咗嘅試管咧就幫我哋收集翻啲氧氣啦。Part A 啦就問我哋啦，我哋喺一個特定嘅時間入面去量度翻究竟收集咗幾多嘅氧氣，從而啦就可以顯示翻呢棵水草嘅光合作用嘅速度。咁根據呢個量度方法咧，背後啦有啲咩嘅假設呢？然後啦解釋我哋嘅答案。咁呢個題目呢，其實就係考緊我哋對於一棵植物嘅正向氣體交換嘅概念。咩叫正向氣體交換呢？就係睇下光合作用同埋呼吸作用佢哋之間嘅速度究竟係咪一樣啦？咁自不然啦，就係考翻我哋呢兩條式啦。第一條式就係光合作用，第二條式就係呼吸作用啦。而呼吸作用咧就會用到氧氣嘅，所以啦，我哋就要回憶一下我哋當初學嘅植物氣體交換啦。幾時會有一個正向嘅氣體交換呢？例如啦，一個正向嘅二氧化碳嘅攝入，或者正向嘅二氧化碳嘅釋出，或者啦喺一個黑暗嘅情況底下，一棵植物咧有一個正向嘅氧氣嘅攝入，同埋啦喺一個超高光度嘅情況底下咧，就係一個正向嘅氧氣嘅釋出。而中間呢一點咧就係補償點，就係光合作用同埋呼吸作用嘅速度一模一樣啦。所以啦，由光合作用所產生嘅氧氣就正正就會俾呼吸作用用咗去啦。例如啦，生成咗6個氧氣，咁呼吸作用亦都會用咗6個氧氣，所以啦就冇一個正向嘅氣體交換。所以啦，呢個題目最關鍵嘅概念呢，就係呼吸作用喺全日嚟計呢，其實係保持一個一樣嘅速度嘅，佢係唔會受到光度所影響。相反啦，受到光度所影響嘅呢，應該係光合作用。所以啦，我哋嘅假設就係呼吸作用嘅速度喺整個實驗嘅途中呢係冇變化嘅。所以啦，呢棵植物喺整個實驗當中所能夠正向釋出嘅氧氣呢，都係建基於光合作用所導致，係因為光合作用比呼吸作用為之快，所以啦就有一個正向嘅氧氣嘅釋出啦，就去解決翻呢人哋挑戰你嘅實驗結果啦。有人可能會講咯，一棵植物啊，佢嗰個呼吸作用啊，時快時慢噶，佢中意快就快，中意慢就慢，又或者啦，我將盞燈擺近啲啊，佢熱啲噶嘛，熱啲嘅話，咁啲 enzyme 咪做得快啲咯，咁個呼吸作用咪做得快啲咯。就當呢件事係真，我哋都要假設佢係不變，因為啦，如果呢棵植物嘅呼吸作用真係喺個實驗嘅期間係改變嘅時候，咁你又從何判斷到呢棵植物係幾時能夠產生多啲氧氣，幾時能夠產生少啲氧氣呢？你就不得而知啦。咁亦都同個光度有咩嘅關係呢？你亦都證明唔到啦。跟住啦，去到 Part B 啦，就要我哋去改良下個實驗裝置。呢個實驗嘅結果就只係受到個 IV 獨立變項或者我哋嘅自變項咧所去改變嘅。然後啦，又係解釋你嘅答案啦。咁其實呢條題目呢，就係考我哋對於變項嘅理解啦。要去解決翻啲 variables 咧，我哋不得不提嘅就係整個實驗嘅目的啦。今日不厭其煩都要提多次啦。整個實驗呢係有分因同埋果嘅。其實啦，今次呢，我哋就想睇下個因就係個光度嘅變化，去導致到呢棵植物嘅光合作用嘅速度，即係個果啦。有啲咩嘅改變呢？咁啊，直接速溫下書啦。個因呢，其實就係我哋嘅自變項，係由我哋去話事嘅。跟住個果呢，就係應變項，就係我哋想去量度嘅。咁而家我哋去改變嘅呢，其實就係個光度。但係點樣改變個光度呢？就係將盞燈移近啲同埋移遠啲嗰棵水草啦。咁所以呢，我哋要改變嘅呢，其實係個距離，從而呢就調節個光度。跟住去到應變項啦，就我哋要量度嘅嘢，我哋今次想知嘅係個果係乜嘢啊？就係光合作用嘅速度。但係點樣量度法啦？就係透過喺一個特定時間入面，我哋收集咗幾多嘅氧氣啦。 咁所以個題目其實就係話啦，我哋要透過改變下個裝置，令到啦我哋所得出嘅結果咧，就只係因為個光度改變而有變化嘅。所以啦，我哋就要排除晒其他嘅變數啦。所以啦，我哋就揾下其他嘅因素啦，都係有機會影響到棵植物嘅光合作用嘅速度，就令到佢喺整個實驗當中咧係不變嘅。咁呢個就係我哋嘅控制變項 control variables 啦，係咪？咁我剛剛咧就講咗個 IV 同埋 DV 啦。咁呢個實驗仲有啲咩嘅 CV 控制變項咧？咁你喺留言區話俾我聽啦，睇下你能唔能夠破解 SBA 啦。咁翻嚟題目啦，成條題目原來就係要我哋去改良個裝置，去確保我哋嘅控制變項咧真係要一模一樣嘅。咁所以我哋頭先就要諗下啊嘛。究竟有啲咩嘅因素都會令到個光合作用都有個變化呢？除咗個光度之外呢，咁整個光合作用其實都係一個生化過程嚟噶嘛，當中亦都有酶嘅參與。咁酶呢都會受到溫度嘅影響嘅。咁所以我哋今次呢就要理解下啦，溫度呢喺整個實驗當中呢應該要保持不變。咁我哋點樣保持不變呢？咁答案呢有兩個層面嘅。第一個咧就係擺個溫度計啦，而第二個咧就係擺一個防熱嘅罩啦，或者啦喺個燈膽同埋個水草之間就擺一個水兜啦，或者啦用一啲係冇咁高溫嘅光源啦，咩例如 LED 咧，同意啦就避免到喺個量杯入面嘅水嘅溫度嘅上升，亦都從而啦去確保個溫度咧係保持不變嘅。咁但係呢兩個答案當中咧，我就覺得呢個答案咧係好一啲嘅。因為樓上呢個答案呢，其實太被動啦。你擺支溫度計插喺個 beaker 入面，咁啊點啫？咁樣只係話俾你聽，個溫度呢而家幾多度咯。咁你將盞燈擺近啲，擺遠啲，你根本係無補於事嘅。你係只係眼白白見到個溫度上升，跟住話啦，大鑊做錯實驗添。喺個實驗過程當中，溫度上升過，你頂多都係話俾人聽，喺呢個實驗當中咧有少少 error 咯，有啲誤差咯，所以我實驗唔準咯。但係你睇下題目，佢要你改良個實驗，去解決人哋對你嘅挑戰，人哋就挑戰你啦。你覺得棵水草整得多啲氧氣真係關啲光事咩？關個溫度事啊！你將盞燈擺得太近啊，好熱啊！乜你冇搞清楚先去整呢個實驗裝置嘅咩？我擺咗一個透明嘅防熱罩呢啦，我擺咗一兜水啦，我用咗一個 LED 燈啦，去解決呢個溫度上升嘅問題。呢個先係改良嘅方法。跟住我到 part C 咧，就翻去光合作用嘅反應啦，就講下咧，究竟喺個光化反應所產生嘅兩種產物，對於整個光合作用嘅過程有啲咩嘅重要性？咁條題目啦，其實就係考下我哋對於光化反應同埋我哋嘅碳固定究竟有啲咩嘅關係啦。咁當中有啲咩嘅化學物質咧，去製造嘢食咧？嗱，留意下題目係問翻整個光合作用嘅過程啊嘛。咁光合作用為乜啦？就係為咗整嘢食啊嘛，係咪？咁當中啦有啲咩嘅化學物係做扣連嘅咧？其實就係 ATP 同埋 NADPH，咁佢哋兩者啦有咩嘅功用呢？ ATP 就係提供能量去推動呢個碳固定。咩叫碳固定啊？就係將啲二氧化碳入咗嚟之後，就掉個 H 俾佢啊嘛。咁啊 H 要冚落去個二氧化碳係咪一個合成代謝啊？合成代謝係需要能量噶嘛，係咪？又或者啦係去重新製造翻個二氧化碳嘅 acceptor 啦。咁啊，因為啦喺 Kelvin cycle 啦，我哋都有二氧化碳嘅 acceptor 嘅。而對於一個 cycle 嚟計，以前我哋解題都講過啦，係由於係一個循環啊嘛，即係有啲嘢係要出翻嚟嘅，咁就係二氧化碳嘅 acceptor 啦。而 NADPH 有咩用啊？就係提供一個還原嘅能力。呢個還原嘅能力就係加翻個 H 落去我哋呢個三個碳嘅化合物，從而啦去製造葡萄糖啦。咁呢一款題目呢，唔係新出噶，過往都有噶。問下你啦，光合作用嘅 ATP 究竟有咩用啦？碳固定需要啲乜嘢啦？光反應究竟有啲咩用啦？16年嗰條題目呢，都有問過噶嘛？類囊體同埋我哋嘅基質究竟佢哋有咩功能性關係？其實咪就係問緊你光化反應同埋 Kelvin cycle 之間嘅關係咯。好，又嚟到一點出發啦。今次嘅題目呢，就係講光合作用嘅。 考我哋兩樣嘢，產生啲乜嘢同埋科學探究啦。產生啲乜嘢呢？就係考翻我哋對於光反應同埋暗反應嘅理解啦。過往咧都啲題目咧去講解俾大家聽噶啦。咁啊，第二啦就係製造啲咩東西呢？今次呢個實驗呢，我哋要去研究嘅就係氧氣，再加埋呼吸作用呢個概念呢，引申出嚟嘅就係氣體交換。而對於氣體交換啦，我哋要理解下一棵植物啦，喺唔同光度情況底下，究竟幾時會有一個正向嘅氣體交換呢？又或者啦，幾時會到一個補償點呢？就係喺一個特定嘅光度底下，呼吸作用同埋光合作用嘅速度係一模一樣啦。然後去到科學探究啦，今次咧題目係冇問我哋個變數嘅，下次問晒你3款變項作為一個題目嘅變奏，有咩唔得啫？今次咧就畫咗個裝置俾你嘅，下次要你畫翻個裝置俾我睇又得唔得？過往都有題目要我哋去畫一個裝置嘅，今次亦都唔例外啦，係咪？而呢條題目新少少嘅就係有關於假設啦。對於假設咧，我就將個光合作用引申多一步，就係講下蒸騰作用其實都有假設嘅。當初我哋去學蒸騰作用咧，就學咗氣泡蒸騰計，佢明明就只係量度緊棵植物嘅吸水。但係啦，我哋就要將佢攣到咬翻直，就話吸水都係失水。就問你背後有咩嘅假設？個假設就係棵植物係冇儲到水分嘅，所以吸咁多就係失咁多。過往我哋都有 MC 啦，或者長題目啦，都考過氣泡蒸騰計嘅。未溫書嘅快啲睇翻咯。217 Question 7 is about the scientific investigation. In the diagram, it shows the experimental setup for investigating the effect of light intensity on the rate of photosynthesis. So you can see in this setup, we have a ruler to measure the distance between the light bulb and the aquatic plant. And in the beaker, it contains the water and the aquatic plant. And we have the inverted filter funnel and the inverted test tube to collect the oxygen gas released by the aquatic plant. So in part A, what is the assumption behind using the volume of oxygen released per unit time to indicate the photosynthetic rate? And explain your answer. In this question, is checking the concept that the net gas exchange based on the interaction between the photosynthesis and the respiration. In these two word equation, photosynthesis word equation and the respiration word equation, we can see that there is a common gas which is oxygen. Plants, when they are under the light, they can produce oxygen by photosynthesis, and the oxygen will be taken up by the plant itself for respiration. So we need to recall the concept of gas exchange of the plant. In this graph, what we learn is the compensation point. It means that the rate of photosynthesis is equal to the rate of respiration. And when the light intensity keep increasing, and the rate of photosynthesis will be higher than that of the respiration, and there will be a net uptake of carbon dioxide, or a net release of oxygen gas. Or in the darkness, the plants cannot undergo photosynthesis and only undergo respiration. Therefore, there will be net release of carbon dioxide or net uptake of oxygen. So in the gas exchange of the plant, we have a critical concept. The respiration takes place all the time at a rather constant rate, relatively constant rate. So the rate, it does not change with light intensity. However, the rate of photosynthesis is greatly affected by the light intensity. Therefore, the assumption is that we assume the rate of respiration remains constant or remains relatively constant, so that any change in the net production of oxygen can be attributed to the change in the photosynthetic rate. In this question, we have to understand that actually the rate of respiration, it may change a bit throughout the day or even throughout the experiment. However, if we really take it in consideration, we shall never measure the actual rate of photosynthesis. Therefore, we need this assumption in order to make a reasonable measurement. And for part B, it asks us to suggest one modification to this experimental setup to make sure that the result is due to the independent variable only, and explain your answer. Surely, it checks a concept about the variables in the experiment. In order to identify the variables, we need to study the aim of the investigation. Again, we are going to investigate the effect of the light intensity on the rate of the photosynthesis. You can see the cause and effect. What we change is the dV, the effect of the 2, 3, 4. So what we change is the independent variable. That's the cause of the experiment. We change the light intensity. We change the light intensity by changing the distance between the light bulb and the aquatic plant. We put it closer to the plant, the light intensity will be higher, and we put the light bulb away from the aquatic plant, so the light intensity will be lower. What is the result we are going to measure? Observe, it is the dependent variable. We are going to observe the rate of the photosynthesis. And how can we measure it? In part A, it tells us already. The rate of photosynthesis is indicated by the volume of oxygen gas collected in the test tube per unit time. So we have the IV, we have the dV, so we have to modify the experimental setup to make sure that the rate of photosynthesis is only affected by the independent variable, which is the light intensity. So we have to determine any factor which will or may affect the rate of photosynthesis. Then figure out any controlled variable which should be kept constant. In this part, I mentioned the IV and dV. So how many CVs can you identify? Leave your answer in the comment section. Let's see how good are you in the SBA. So for this question, the critical skills is to modify the setup to ensure CV is kept constant. So we need to think about that. Photosynthesis is a biochemical reaction, and the biochemical reaction is speed up by the enzyme, and the activity of the enzyme is affected by the temperature. So temperature is also a factor may affect the photosynthetic rate. So how can we make sure that the temperature of the whole setup is relatively constant or is constant throughout the experiment? So the first method, we place the thermometer in the beaker, and the second method, we add a heat shield, water bath between the light bulb and the beaker, or use the cold light source, for example, the LED, to conduct the experiment. And by doing this, we can make sure that the temperature is constant, or to avoid the heating up of water in the beaker. But for these two answers, which one is better? In my opinion, is the second one. Because for the first one, we just put the thermometer in the beaker. It doesn't make sense. It just shows you that the temperature, it changes. And you can do nothing. You may just able to write down that in your experiment report. In the report that there is an error or even a mistake in the experiment because the temperature changes. But for the method 2, we really do something to modify the experiment, prevent any temperature changes. And for part C, it asks about the reaction in the photosynthesis. What is the significance of the two products of the photochemical reactions to the whole photosynthetic process? For this question, is checking the relationship between the photochemical reaction and the carbon fixation, which is the Calvin cycle, and recall the chemicals which are required to produce food by photosynthesis. You need to recall that the ultimate goal of photosynthesis is to produce food. So how do we produce the food? Or we need the carbon dioxide to produce the carbohydrates. So what do we need? We need the ATP and the NADPH. So as the ATP, it provides the energy to drive the light-independent reaction. For the carbon fixation, to add the hydrogen to the 3C compound, which is a anabolism, building up reaction. And for the building up reaction, we need energy input, right? So we need ATP. Or the ATP is used for the regeneration of carbon dioxide acceptor. Because for the carbon dioxide acceptor, they work in the Calvin cycle to bring the carbon dioxide into the Calvin cycle for the chemical reaction. And for the NADPH, it provides the reducing power for the reduction of 3C compound to form glucose. What is the meaning of reduction of the reducing power? It means the addition of the hydrogen atom to the 3C compound. In the past, there are MC and long question asked about the light reaction, carbon fixation, ATP in photosynthesis, and also in 2016 question, it asks you the collaboration, the functional relationship between the thylakoid and the stroma, which is testing your concept about the photochemical reactions and the Kelvin cycle. And let's take a look at the curriculum mapping. This question, it starts from the photosynthesis experiment. And there are two concepts we are checking, products and the scientific investigation. So for the product, we need to recall the concept of the light-dependent reaction and the light-independent reaction. So in the past, we have the MC long question to check this concept. And in this question, we focus on the gas, the oxygen gas production. And we combine the concept with the respiration, so we can talk about the gas exchange. For the gas exchange in the plant, we need to consider the light intensity. So at which degree of light intensity, the plant will reach the compensation point. That means the rate of photosynthesis is equal to the rate of respiration. Then let's talk about the scientific investigation. In this question, it doesn't check you the concept about the three variables. Next time, it can ask you to identify the three variables. Meanwhile, it can also ask you to draw the setup. So in the past, we have the long question to draw the setup, right? This time, the question is very good. The diagram is given, so maybe next time you need to redraw it by yourself. And then for the assumption, it is a bit new thing for this experiment. And I would like to extend the concept to other chapter. It is transpiration. So in transpiration, we study the bubble potentiometer. Actually, it's measuring the water intake. However, we need to make it to the water loss. So we need an assumption, and the assumption is that there is no water retention in the plant. For how much water does it uptake? It will equal to how much water does it lose. You can check the potentiometer experiment assumption for the MC question or the long question in the past.